So now I want to ask you a more difficult question. One volunteer to give me the answer. Anybody is ready to tell me, to give me the answer of the questions? Nobody. I know. Nobody will do it. You're a graduate. You know, freshman students were much better because they raised the hand and they were ready to interfere, to give it. But now what happens? So, which is the order parameter in an antiferromagnet? Who wants to tell me? Okay, your face were telling me that you wanted to, but you dare.
Order parameter is the temperature. No?
The order parameter is a parameter that is zero above the transition and non-zero below the transition. So temperature in the paramagnetic state is not zero. So it cannot be. Magnetization in a ferromagnet is zero in the paramagnetic state at zero field and becomes spontaneous, non-zero, below the transition temperature. The problem with an antiferromagnet is that magnetization is zero, also below the ordering temperature. So that was why my question. You have to think which the parameter could be, but temperature is not. I'm sorry. Who has an answer? This is becoming interesting. I know his face. I saw. Good. The first hand going out. Good.
Order parameter is magnetic susceptibility.
I wouldn't say that. Why? Because magnetic susceptibility in the paramagnetic state and in the antiferromagnetic state has no discontinuity. It's true that there is a difference because it becomes anisotropic, and if you have a single crystal, you can distinguish between parallel axis and perpendicular axis. But if you have a powder, you can't. So I wouldn't say that the susceptibility is the order parameter. Also, the susceptibility is not a parameter. It's not a parameter, not a thermodynamic parameter of a material. You see, it's a relation between magnetization and field. In fact, it's a tensor, a second order tensor. So I wouldn't say that. No. Okay, it's very, very interesting. Anybody there? This is. Okay. An order parameter, did you think about? Let's ask a lady. Any of you think about? Okay. You have an idea of which the order parameter can be? Right. Fantastic. Fantastic. Right. This is. Exactly. And let me tell you, I have a theory which almost 100% of the times is confirmed. Women are more intelligent than men. And again, I can see it's true. Very good. Thank you very much. Thank you very much. Arigatou gozaimasu. is the sublattice magnetization. Because you see, you have a ferromagnetic lattice. It's very easy. You have the magnetization, the spontaneous magnetization. In an antiferromagnetic lattice, okay, you have, in fact, two sublattices. This is A sublattice, but you also have the B sublattice. A sublattice, the moment is up. B sublattice, the moment is B. So if you only consider one sublattice, A, then you are like in the ferromagnetic case. And now you can ask me, okay, this is very good, but how can I measure A sublattice? I will measure everything. So magnetization is going to be 0. And I will ask you, please, wait until the second part of today's lecture, where we will see that we can measure magnetic structures with neutrons. And neutrons can give us the sublattice magnetization because they can give us information about the magnetic structure. So if we know the magnetic structure, it's like the crystallographic structure. That neutron people never talk about crystallographic structure and magnetic structure because both are crystallographic structures. One is with the crystallographic space group, the other one is with the magnetic space group. Okay? So we talk about nuclear structure, the structure of the nuclei, which is what you commonly say crystallographic structure, but we prefer to say nuclear structure and magnetic structure because both are crystallographic. Okay? So, sublattice magnetization is the answer to the question. Very good. Thank you very much. So, the second question was in your leaflet, so you know it, which is the interest of critical phenomena. Who wants to give me an answer in this row? Good. I couldn't.
So magnetization divergence.
The critical phenomena. But that doesn't give you useful information. You want to do a lot of work because measuring critical exponent requires a lot of work. If you ever have to do it, you will see that it's very hard because you have to be extremely careful. So you want to take advantage of all this effort. So just to see a divergence is not very informative. You want more.